So gasoline has a density of 0.56 grams per centimeter cubed. What's the volume in deciliters of 75.0 kilograms of gasoline? So we're given two things. We're given the density and we're given 75.0 kilograms. So what are we going to start with? Well, I recommend you notice that there's a more complex unit here. So we could write density as 0.56 grams over 1 centimeter cubed. So when you see it that way, you can notice that you might want this on top at one point, or maybe you want this on the bottom and the centimeters cubed on top. And we don't really know which way we're going to use that in this case. So I'm going to recommend that you always start with the less complex unit, which in this case is 75.0 kilograms of gasoline. All right, now we're going to want to get, it says volume, that's what we're looking for. We're ultimately looking for deciliters. So we need to get rid of kilograms, and you'll notice here's grams. So we're going to have to somehow get grams on the bottom, but they're not the same unit. So I need to change kilograms into grams. And you know the conversion factor, you always put the power of 10 in front of the basic unit. Grams is the basic unit. So now we've gotten rid of kilograms. And now we want to get rid of grams. Again, we're trying to get to volume. So now you can see that if I put these grams right here on the bottom and centimeters cubed on top, centimeters cubed is volume, and that's what we're ultimately looking for. So I'm going to put centimeters cubed on the top. And I'm going to keep the number with the unit. You might be tempted to put 0.56 here, but don't do that. 1 is what goes with centimeters cubed, and 0.56 goes with grams. So now we've gotten rid of mass and we have volume, which is what we're looking for. Notice that we had to use the inverse of the density to go from mass to volume. Okay, now we've got centimeters cubed, and this step is probably optional, but I want to get rid of centimeters cubed and get milliliters. So you know that's a 1-to-1 ratio. You don't necessarily need to show that, but that gets us with the liters at least. So we're going to get rid of milliliters and get liters, because I'm ultimately wanting to get to deciliters, and I know I can go from liters to deciliters, so that's why I went from milliliters to liters. And so 1 goes in front of the unit with the prefix, and then our power of 10 goes with the basic unit, 10 to the minus 3, and then 10 to the minus 1 down here. Okay, so how many significant digits do we have? Well, you can see right here we've got 2 significant digits. We've got 2 sig figs, and this, so then when we put this in our calculator, we get 1,339.28574. Some very long number from our calculator, but we want 2 digits. And so we can't just cut this off here. We need to put it in scientific notation. There's our 2 digits. So we're going to have to round at this point. Okay, so that's 1.3 times 10, and it's going to be 10. We move the decimal place over 1, 2, 3, so it's 1.3 times 10 to the third deciliters. So we went from kilograms to grams, centimeters cubed, to milliliters, to liters, to deciliters. And we have 1.3 times 10 to the third deciliters. That's our answer. But remember, to get to this, we had to use inverse of density.